Welcome to The Explainer. Today, we're diving into a really cool piece of engineering, one that was basically invented to solve what seems like an impossible problem in construction. So picture this. You've got these jobs that just seem to defy access, right? We're talking about working at dizzying heights in the most awkward places imaginable. Think about maintaining the facade of a historic cathedral or cleaning a massive glass atrium, even just trimming trees in a super tight garden. They all have the same basic challenge. So, how do you get to those unreachable spots? I mean, how do the pros safely get into places that are way too high for a ladder, way too tight for a crane, and just too delicate for your standard clunky lift? Well, the answer is pretty amazing. It's a machine that actually gets its big idea from the natural world. All right, let's break this down. The super technical official name is a tracked aerial platform. Yeah, it's a bit of a mouthful, isn't it? That's why pretty much everyone just calls them by their way cooler nickname, spider lifts. And you can see exactly why they got that name. With those outriggers deployed, it looks just like a spider. The whole idea is that it can crawl into a really tight space on its tracks, and then bam, it spreads out its legs, the outriggers, to create this super wide, super stable base. And that's the core principle, right there. You're combining immense reach with this super agile, compact body. It's this dual nature that's the secret sauce. It's the key to their genius, really. It lets them get into places where other heavy equipment has zero chance. Okay, so let's get into the fun stuff. Just how extreme can these things get? Let's talk about mastering height and reach. Yeah, the range is just huge. You've got smaller models like the Bluelift SA11, which goes up to about 11 meters, perfect for indoor maintenance. But then you scale all the way up to mid-sized machines like the CTE model, which can handle really serious construction jobs at 23 meters. But the engineering pushes the limits way, way further than that. Get this, the platform basket 54T can reach a working height of 54.1 meters. I mean, that is absolutely staggering. To put that in perspective, that's like working on the roof of a 15-story building. And listen, it's not just about going straight up. That's only half the story. It's also about reaching out, over obstacles. This is what's called horizontal outreach. And check out these numbers. Some of these can reach out 18, 19 meters horizontally. That allows an operator to just park the machine once and then access this huge working area, reaching way over rooftops or tricky terrain or whatever other barriers in the way. It's a total game changer. But, all that incredible reach is completely useless if you can't even get the machine to the job site. And that brings us to conquering confined spaces, which is where the spider part of the spider lift really, really shines. Okay, so this is the crucial part. Look at these widths. A lot of these incredibly powerful machines are designed to be less than 80 centimeters wide when they're all packed up for travel. Think about that. Your standard single doorway in a house or an office, that's about it. They can fit right through. I mean, it says it right there in the brochure for one model. It goes through a standard door and fit in the lifts. So you can literally drive it inside a building, put it in an elevator, and get to work inside huge places like airports or shopping centers. It's wild. This comparison right here just shows you the incredible transformation. We're talking about going from a stowed width of less than a meter, so it can fit through a garden gate, to a working footprint that's almost 5 meters by 5 meters. That's the whole magic trick right there. So let's move on. We've seen how they get into these crazy tight spots, but once they're there, these machines are so much more than just a lift. Let's talk about their power, features, and just how versatile they are. To be able to work literally anywhere, you need options, and they have them. You can get them with petrol engines, diesel engines for remote outdoor sites, you can get an AC electric motor, or even run them on lithium-ion batteries. Some are even hybrids. This is what lets them work anywhere, from the middle of nowhere to inside a hospital with zero emissions. And their usefulness goes way beyond just lifting people. I mean, some of these are marketed as a real mobile crane. And they're not kidding. You can get these things with a hydraulic winch that can lift up to 1,000 kilograms. Most of them have tool lines running right to the basket, so you have air, water, and power right where you need it. And the controls are getting smarter and smarter with things like automatic leveling and remote diagnostics. They're basically evolving from a simple lift into this incredible multi-tool work platform. So what's the future of access? When you really look at it, the story of the spider lift is all about incredible specialization. It's about brilliant engineering trade-offs.
And that's the main takeaway, you know? Every single one of these machines is this finely tuned balance, a balance of height, outreach, weight, and compactness. It's all designed to solve a very, very specific problem. So there's no single best machine. There's just the perfect tool for an incredibly difficult job.
So, as engineering keeps pushing these machines higher and farther and into even smaller spaces, you have to ask, what new challenges are we going to be able to solve? What impossible places will we be able to reach next?